So let us convert the right linear grammar into the finite automata. So when you're converting the right linear grammar into the finite automata, the number of states in the finite automata will be equivalent to the number of non-terminals in the grammar plus one state. And this one state is going to be act as the finite state. So first you have to verify whether your grammar is having any epsilon productions. If the grammar is having epsilon productions, you have to remove the epsilon productions. After eliminating epsilon productions, you don't forget to keep epsilon for the start symbol if it is already having. And each non-terminal in the grammar will represent a state in the finite automata, and add an extra state called f as a final state. Set the start symbol as the start state. If your start symbol is having epsilon productions, you have to make the start symbol as a final state. Okay, if your start symbol is having epsilon productions, you can also make the start state as a final state. For every production in the form of A tends to AB, you have to add a transition from state A to state B labeled with terminal A. For every production in the form of A tends to small a with only one terminal on the right hand side, you have to add a transition from state A to the final state, labeling the edge as small a. So remove epsilon productions, and every non-terminal will represent as the state in finite automata. And you have to add one extra state as final state and make the start symbol as start state. If the start symbol is having epsilon productions, make start symbol as final state. For every production in the form of A tends to small a capital B, add a transition from A to B labeled with terminal A, where A is a terminal symbol. For every production A tends to small a, where A is a terminal, add a transition from A to the final state with label A. So let us see this grammar. So this is right linear grammar. If you observe this grammar is having epsilon productions. First, let us remove the epsilon production. So to remove the epsilon productions, first write the grammar as it is without epsilons. First write the grammar without epsilon production. And to remove the epsilon production, you have to replace the non-terminals which is having the epsilon productions wherever they appear. For example, if you observe that S is having epsilon production. So what you have to do is wherever there is S, replace S with epsilon and add the result as a new production. So here you have AS on the right hand side. So replace S with epsilon and whatever you get and you add them as a new production. Here also you have S on the right hand side. So S derives epsilon. So if you replace S with epsilon, so you will get C as a new production. Similarly, and B is also deriving epsilon production. So wherever there is a B, replace B with the epsilon on the right hand side, and whatever the result you get, you add as a new production. If you observe this, and this is having B, replace capital B with epsilon. So whatever you get as a result, you add them as a new productions. So here S and B both derives epsilon production. So wherever S and B appears on the right hand side, replace them with epsilon production. Whatever you get as a result, you add them as a new production. So this is the grammar after eliminating epsilon production. And don't forget to add epsilon to the start symbol if you already have epsilon. Okay, so you are not supposed to remove epsilon from the start symbol even after substitution. Okay, so when I say epsilon, when I say S derives epsilon, so S is a final state. S can also be a final state. So this is the grammar after eliminating epsilon productions. Now let's convert this grammar into finite automata. If you observe this, there are three non-terminals S, A, and B, and each non-terminal will be acting as a state. Each non-terminal will be acting as a state. And as I said earlier, you have to add one extra state also called as final state. You have to add one extra state called as F as a final state. As per this formula, if F is having epsilon production, you have to make S is also as the final state. As S is having epsilon production, so I am making S also as a final state. Okay. So the next one, you have to convert each of these productions into transitions. If your production is in the form of A tends to AB, so you have to add a transition from A to B on input symbol A. If you have production like A tends to AB, you have to add transition from A to B on input symbol A. If you have a production like this, A tends to small a, so you have to add a production from A tends to the final state on input symbol A. Okay, so let us do one by one. So any productions will be either in this form or in this form. So the first production is the second format. So you have to add a transition from start state to the final state on input symbol A. And the second one, this is S tends to small a capital A. So you have to add a transition from S to A on input symbol A. Similarly, you have S tends to BB, which means you have to add a production from S to B on input symbol B. And you have S tends to B as this is a terminal string, so you have to add a transition from S to a final state on input symbol B. S to final state on input symbol B. So S productions are finished. Let's do A productions. If you observe this, A tends to small a, capital A, which means you should add a transition from capital A to capital A on input symbol A. So add a transition from A to A on input symbol A. And similarly, you have production A tends to AS, which means you have to add a transition from A to S on input symbol A. And the next production is A tends to small a. So if it is A tends to small a, you have to add a transition from A to final state as it is a terminal string on input symbol A. Similarly, B is having two productions. B tends to CS, which means you have to add a transition from B to S on input symbol C. And the next production is B tends to small c. So as C is a terminal, so you have to add a transition from B to the final state on input symbol C. Okay, so this is the way how you are supposed to construct a finite automata for the given right linear grammar. Let us discuss the next example. Here, the grammar does not have any external productions. You can straight away constructing a finite automata. So there are three non-terminals A, B, and C. So the total number of states is going to be 3 plus 1. A, B, C, and F is the final state. So you can make the start state as a final state if start state is having epsilon productions. As start symbol does not have any epsilon productions, you should not make it as a final state. So this is the states. There are 4 states. A, B, C are non-final states, and F is the final state. So let us draw the transition. This is A tends to small a, capital B, which means you should add a transition from A to B on input symbol A. The next one is A tends to BA, so you have to add a transition from A to A on input symbol B. And if you observe this, A tends to B, as it is a terminal string, so you have to add a transition from A to the final state on input symbol B. Let's do the same for B. B is having 2 production. The first production is B tends to A, capital C. So you have to add a transition from B to C on input symbol A. And the next one is B tends to small b, capital B. So you should add a transition from B to capital B on input symbol B. Similarly, for C is having 3 productions, so you have 3 transitions. The first one is C tends to small a, capital A, which means you have to add a transition from C to A on input symbol A. And the next one is C to BC, so you have to add a transition from C to C on input symbol B. And the last one is a terminal string, so you have to add a transition from state C to the final state on input symbol A. So this is the way how you are supposed to convert the right linear grammar into finite automata. So these are the some of the problems you can practice, set of terminals, and this set of variables, and these are the productions. So this is the set of terminals, this is set of variables, and this set of production. And in all this, S is the stat symbol. So you can practice this as your exercise problems.